In this video, we're going to talk about physical and chemical changes on the basic chemistry level for a course. And so it's important that we need to have that basic knowledge of a physical and chemical change. So it is important to understand the difference between chemical and physical changes. Some changes are more obvious than others, but some of the basic ideas you just need to have a background knowledge of. So physical changes are usually about physical states of matter. So, solid, liquid, gas, etc. Now, chemical changes, on the other hand, they happen on a molecular level when you have two or more molecules that interact. And that interaction usually produces something for us. It produces heat, it produces gas bubbles, so forth. So chemical changes happen when these atomic bonds are either broken or they're created during chemical reactions. So let's talk about just a few examples here in the introduction. If I was to step on a soda can and crush that soda can, to the ground. Well, if I do that, that soda can is still that soda can. It's just in a different state. So you've only changed the shape of that can. It wasn't a change in the state of matter because the energy in the can did not change. So basically, since that was a physical change, the molecules in the can are still the same molecules. So basically, you've not created a new bond and you've not broken a bond. So there was nothing created or broken in that example. Now, when you melt an ice cube, for example, you have a physical change because you've added energy. You added enough energy, of course, to create that phase change is all. It's still water. You've just basically change the form of it. So physical actions such as changing temperature or pressure can cause physical changes. No chemical changes took place when you melted the ice. The water molecules are still the water molecules. Now, when you talk about chemical changes, of course, happen on a much smaller scale. While some experiments show obvious chemical changes, the color change, the heat, and so forth, most chemical changes may not be visible, actually. So the chemical change as hydrogen peroxide becomes water cannot be seen since both liquids are clear. However, behind the scenes, billions of chemical bonds are actually being created and destroyed in this reaction because we see the evidence of oxygen gas. That's the bubbles that you see forming, and those bubbles give us our evidence of a chemical change. So that's just a quick introduction there of physical versus chemical. So we're going to go through a few slides here talking about some different examples to get us a basic knowledge. So a physical change alters the form of a substance but does not change it to another substance. Making orange juice. We are altering the form of this orange, but we're not making a total different new substance. It's still orange, it's just in the form of juice and liquid instead of a solid. What is a chemical change? When a substance undergoes a chemical change, it is changed into a different substance with different properties. So we baking a cake. First of all, anytime you involve heat, usually that's an indication of a chemical change. So you started out, with liquids, it was raw eggs and, raw cake, batter and so forth. And you have formed a whole different substance through using heat. You've baked those substances, so you have an entire different substance from that reaction with heat. So therefore, bonds have been formed there. So that's a chemical change. 5 signs of a chemical change. 1, color change. Leaves changing color in the fall. That's a great example there of a chemical change. Precipitation, as I mentioned, anything that you can visually see. Precipitation, the solid that forms from a solution during a chemical reaction. It looks like a cloudy solid in an otherwise clear solution. Number 3, gas production. Anytime you have bubbles, you're going to always think chemical change. Temperature change. Anytime you have a temperature change, something is happening. Bonds are being created or destroyed. Fireworks, for example. You start out with, a small substance in your hand. You light it, you add fire to it, and you add heat to it, and it explodes. Any kind of explosion obviously would be a chemical change. And changes in characteristic properties. Odor, light being given off is a great example there of a sign of a chemical change. So chemical or physical here. Cutting paper, Obviously, on the physical aspect of it, you're cutting the paper, you're changing its form, I guess you could say, as far as it's not a whole sheet of paper, it's going to be small giblets of paper. Regardless, it's still paper. You've not changed anything about that other than the shape, just like crushing the soda can. So we're still dealing with a physical change here. Ice melting, again, physical change. The ice is water. It is just in the frozen state, and it's going to melt, and it's still water. Nothing has changed about that, so it's physical. Toast burning. A good hint here, anytime you're involving heat, there's been a temperature change, you're going to be dealing with chemical change. So this toast is not only bread, it is burnt bread at this point. So it has involved heat, and it is a chemical change. Rocket fuel burning, again, here's light being given off. There's heat involved. You're dealing with a chemical change. Sawing of wood. Sawing of wood is physical because you are sawing the wood. You may be sawing it into 2 pieces or 3 pieces. Regardless, it's still that wood. There's been nothing to be created or destroyed in that aspect. So it is physical. Metal rusting. Now, this is obviously chemical. This is going to happen over a period of time. Through temperature changes. Anytime you have a temperature change, you're going to be dealing with a chemical change here. So that rust forming on that metal is a formation. That is a chemical reaction. There had to be a chemical reaction to take place for that rust to form. A disappearing puddle. That would be water, and it is going to do what? If it disappears, it's going to evaporate. That's just a state of matter change. Solid, liquid, gas, it's going to evaporate back into the atmosphere. So that's just a physical change. Candle burning, anytime again you're involving heat, giving off light. This is dealing with a chemical change. And dry ice. That might be a little tricky one. It's just a different form of ice. It's still dry. It's still ice. It's just in a different form. Nothing has been created or destroyed here. So you're dealing with a physical change. That's just a few examples and a quick video slide here to discuss chemical versus physical change. Thank you.